Hello, today we are going to learn about displacement vectors. Now a displacement vector is the difference between an object's initial position and its final position. So if I start here and end there, say if I moved 5 to the right and 2 up, 5a plus 2j would be a displacement vector. We've been doing these before, but we've also learned about position vectors that have to start at 0, 0. A displacement vector doesn't have to start at the origin. It could be anywhere. It just is going from one place to another. Now, given a point P at 5, 3, 1, 2, 3, 4, 5, 1, 2, 3, that point is P, and Q is at 7, negative 2. So if that's 5, 7, negative 2, that's going to be our Q. We want to find PQ. So going from P on to Q. Well, we move 2 to the right, so that's going to be 2i. We're going to go down 1, 2, 3, 4, 5. So PQ is going to be 2i minus 5j. Now, if PQ, we can get that by taking vector Q minus vector P. So assume that vector Q goes out like this, vector P goes like that. We can get PQ, so we can find the length of any vector by taking the second one, where it ends up, minus its initial position. So Q is 7, negative 2, and we subtract this from 7 minus 5 is 2, negative 2 minus 3 is negative 5. I could get QP by taking P minus Q. So we would take 5 minus 7, which would be negative 2i, 3 minus negative 2, which would be plus 5j. Notice that these are opposite vectors. They're just going in the opposite direction. It's going from Q to P. Alright, now we get into a tricky question. Given point P 5, 3 and Q 7, negative 2, find the position vector that's 3/4 of the way from P to Q. Alright, so we want to find a position vector, so it's going to start from 0, 0, and it's going to go 3/4 of the distance between P and Q. So from P, half would be about there, so 3/4. That's just a guess. Hopefully it's a good guess. We'll see. Now we have to go to P, and then we have to come down there in order to figure out this vector. So I could take vector P and add 3/4 of the distance of PQ. So 3/4 of this would be 0.75 times 2, which 2 times 0.75 is 1.5, so 1.5i, and 0.75 times 5, so we would go down 3.75j. So P is nice and easy because it's just 5i plus 3j. Now if we add these two vectors together, we'll get this vector, because it goes from the beginning to the end, beginning of one to the end of the other, and then that would give us this point. So if I add these together, 5 plus 1.5, that's going to be 6.5i, and then 3 minus 3.75 would be negative 0.75j. So that would tell us that this point right here is 6.5, negative 0.75. But it asks for the position vector that's 3/4 of the way, and that is this. That's the position vector, but this would be the point if they ask for the point. Alright. So given R and Q find RQ. Now we could draw this out, but RQ is the same thing as Q minus R, which Q would be 1. 1 minus a negative 3 would be 4I. 5 minus 10 would be negative 5J. Now let's see how accurate that is to our drawing. So let's do this. So point R is negative 310. So negative 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Q is 1, 5. 1, 2, 3, 4, just to make sure. So if this is R and that's Q, from R to Q would be that vector. So that's R and that's Q. This is a displacement vector that moves to the right. 1, 2, 3, 4. Good, we got 4 right. 1, 2, 3, 4, 5 down. So both graphically and algebraically, we figured out that is 4I plus or minus 5J. Now if we wanted to find QR, that's just the opposite of this, which is negative 4I plus 5J. Now, given those points, find the point that's 20% of the distance from R to Q. Now, 20% of the distance. So if that's the whole distance from R to Q, 20%, I would guess, I'm just going to take a stab in the dark and say right there. Now to find that, what I would have to do is first go to R and then cut back here. Maybe I should do that in a different color. Let's do it in the same color I did last time. So I'm going to go up to R, and then I have to cut back. If I add this vector and that vector, I'll get the position vector that's 20% of the way. And that would also help us find the point. So R is a nice easy vector, negative 3I plus 10J. This vector is going to be 20% of this. So 0.2 RQ would equal 0.2 times 4, which would be 0.8I, 0.2 times 5, which would be minus 1J. So I'm going to move 0.8 to the right and 1 down. So it's actually at that spot. It's pretty close. A little bit off though. Now, if I add these together, this would be negative 3 plus 0.8, which would be negative 2.2I, and this would be plus 9J. So that means that this point here, which they ask for the point, is negative 2.2 comma 9. All right, hopefully that makes sense to people. It's a tough problem. Now you guys try this one on your own. Pause the video. Find the position vector that is 1/4 of the distance from L to M. Pause the video, and when you're ready, start it back up. All right, LM is going to be M minus L. So 5 minus 1, which is 4I. 3 minus a negative, first 9 minus a negative 3, it's going to be 12J. So that's LM. So if I want to find the 1/4 of the distance from L to M, first I need to go to L, and I'll have to add 1/4 of the distance of LM. So L is 1, negative 3, and I'm going to add 1/4 of 4, 12. 1/4 of 412 is going to be that's going to be 1, 3. So if I add these up, 1 plus 1 would be 2, and negative 3 plus 3 would be 0. So this would be the point that is 1/4 of the distance from L to M. Now let's just take a second and draw this out and see if it even comes close. See how reasonable our answer is. 1, negative 3 is going to be looking like this. 5, 9. 1, 2, that's 4, 5. 9 would be up here. So the vector L to M is that vector. 1/4 of the way, it could be about right there. And my scales aren't accurate at all, but that looks like it could be close to 2, 0. So that's fairly reasonable of an answer. So so it looks like 2, 0 is the point, 1/4 of the distance from L to M. All right. Now this is a question out of our book. Archaeologists often cut a trial trench through an archaeological site to reveal different layers under the topsoil. This helps with dating the artifacts that lie underneath and identifying any geological movements that might have disturbed the original position of the objects. They usually lay a grid on the site like a coordinate system. They dig a trench from point C to point D with distance in yards. Make a sketch of the situation. Alright, here's our coordinate system. They're digging from point, since it's all hundreds, we can do 1, 2, 3, 4, 500. 1, 2, 300. 1, 2, 300. And so let's put on the point D 400, 500. Ooh, 500, we need this a little bit larger. One, two. 1, 2, 3, 4, 500. That's D. 200 negative 300 is C. Write position vectors for C and D. So the position vector of C is going to be 200I minus 300J. The position vector of D is going to be 400I plus 500J. And the vector from C to D is going to be 400 minus 200, which is 200, 500 minus a negative 300, which is 800J. And we can see in this diagram, we'll move 200 to the right, 1, 2, 3, 4, 5, 6, 7, 800 up. The crew finds remnants of a wall 65% of the way from C to D. Write a vector from C to that point. So that's going to be 65 of the distance from C to D. So that's 0.65 times our 0.65 times 200I plus 800J. So 65 times 200, I think that's 130. So that's 130I. 800 times 0.65 would be 520J. Now, that's just the displacement vector 65% of the way from C to D. How long would the trench from point C to the wall remnant? So that's 65% of the way. So that's somewhere right there. So what's that distance from here to here? Well, we know that it's 130 units to the right, 520 yards up. So the distance along the diagonal, along that vector, we could use Pythagorean theorem for. So 130 squared plus 520 squared, and we square root that. We get an answer of 536 yards. What is the position vector to that point? So now we want to find the position vector to that point. So the position vector is starting here and going to that point. So to find that, first we would have to go to C and then add 65% of the way there. So we would do vector C plus 0.65 of CD. Now vector C is 200 minus 300. So we have 200I minus 300J. And 65% of CD is 130I plus 520J. So if we add the i's, it's going to be 330I, and these j's would be 220J. So this would be our position vector, 330 to the right, 220 up. How far would it be from the origin to that wall remnant? Well, now we just need to use Pythagorean theorem. 330 squared plus 220 squared, and square root that. So that would be 396.6 yards. And I kind of went through that quick. The reason why we use Pythagorean theorem, this means it's 330 to the right and 220 up. So that distance there we can find using Pythagorean theorem, because that would be a right angle. Alright, hopefully that's enough to get you through this homework. 5 through 9, 11, and 12. Good luck.